Good morning, everybody. Last time we talked about command line arguments in Java. The command line arguments in Java are handled very similar to C. The environment, Java runtime environment, Java virtual machine, accepts the command line arguments as string arrays like that. And we can check the length of the number of the parameters passed. In this example that we have seen last time, if we look at the output, when you say Java is named for the Java virtual machine, init array is our program, okay. When you say Java init array, it says that you did not start this program correctly. It needs 3 parameters, array size, initial value, and increment. When I provided them, okay, array size is 5, the initial value is 0, and the 4 is the increment. Then it makes a new array, and this new array will have values from 0 to 16 with increments of 4, and I can do the same thing here. Okay, so a very simple program, just an example that shows how to use the command line arguments in Java. Okay, let's move on. Let's look at some constructor stack stuff. Like we did in C++, Java lets us employ more than one constructor through overloading. You could use many constructors for the same class, and like in C++ 11, the constructors can invoke each other. Okay, so let's, instead of talking about this much, let's see an example. We will have a class that represents time. Okay, do I have a sample output? No, I don't have a sample output. Okay, so this time class has 3 private integers, hour, minute, and second. This is how we represent time. Okay, and this time class has 1, 2, 3, 4, 5 constructors. Okay, let's look at the most general constructor. Okay, so this one, line at 30, this constructor, line 30, takes 3 integers, hour, minute, and second, and it calls the setTime method to set the time. SetTime is very simple. It just calls set hour, set minutes, and set second, and each one sets the corresponding time member. I think it does the error check too. I don't know. I didn't get it here, but it does the error check. I mean, if hour should be between 0 and 23, and minute should be 0 and 59, etc. So this one called set time. Let's look at this other constructor methods. The constructor that doesn't take any parameters would call the constructor that takes 3 parameters with these values 0, 0, 0. This is how you call other constructors in Java. Okay, you would use this keyword. We have this keyword available in Java, and you would call the other constructors. Remember how we do this in C++ 11? We would do like this. We would say time to 0, 0, and 0. This was the C++ way, but we are not doing C++ here. Okay, so, and the second one is int h, this h00. Okay, again, I am calling the constructor that takes 3 parameters, and this one, it will take hour and minute, and it will set the second to 0. Okay, you understand it. Okay, and this is the one that we looked at. This is a kind of a copy constructor, right? This is a copy constructor. In Java, we don't have the concept of copy constructors. Okay, there is no term specifically used for copy construction. Okay, but you are free to write a constructor like this, and it is up to you whatever you call it. But the Java compiler doesn't call it. I mean, for a Java compiler or Java language, copy constructor or this type of constructor doesn't have a special meaning. It is just a constructor, because in C++ it was important. Why? Because whenever we need to make a copy of an object, okay, like call by value or the initialization, or when I am returning by value, right, the copy constructor is called automatically, right? That was the idea. That's why the compiler has to know about it. That's why compiler says that if you don't write a copy constructor, I'm going to write one for you, and you may not like it from time to time. Java, we don't have such a thing. Okay, Java doesn't make copies of things without your knowledge, because in Java we don't have call by value of objects, right? In Java we don't have it. We don't have call by value of objects. All the objects are call by reference. Okay, and when you return an object, you don't return object actually in Java. Okay, you return references to the objects, pointers to the objects, because in Java the language doesn't let you handle the object yourself. You can have only the references to the objects. Okay, so in Java we don't have those kind of situations. Of course, that doesn't mean that you are not going to make any copies of objects. Sure, you will make copies of objects. Yeah, that's true. But whenever you need to make copies of objects, you will do explicitly yourself. Your objects will not be copied under the hood without showing you implicitly. Okay, so this is our constructor, just a constructor. I mean, this constructor is as special as this constructor. Okay, and set time is like that. Okay, so why did I show you this program? Because we are talking about overloaded constructors. Okay, and these constructors can call each other like in C++ 11. C++ 98 doesn't have this feature, as you remember. Okay, so let's talk about destruction. As I said before, Java doesn't have destructor methods. There is no destructor. Word destructor in Java doesn't mean anything. Okay, so but you might say that why wouldn't I? Okay, why we don't have a destructor? Because I mean, maybe I shouldn't say there is no destructor in Java, but there are similar methods. Okay, let me put it this way. There are no destructors in Java, but there are similar methods, and we call them finalized methods. Okay, remember at the beginning of Java talk, I told you that Java, if Java contains a keyword which is the same as the C++ keyword, the meanings are the same. So Java talks about constructors. The meaning of constructor in Java and the meaning of constructor in C++ is the same. The meaning of class and the meaning of class in Java and C++ are same. Public, private, protected, the meanings are the same. So if the names are the same, then the meanings are the same. Okay. In Java, we have constructors which are very similar to C++ constructors, but in Java, we don't have destructor. Instead, we have finalized methods. And finalized methods are somewhat different from destructors. Okay, finalized is this. All classes in Java have the finalized method. That's one thing. Okay, we will talk about this later. Okay, finalized is called by the garbage collector. In Java, we have this garbage collection. What is garbage collection? Okay, Java, as we talked about many times, in Java, you don't use delete operators. There are no delete operators. Okay, whenever the number of references to an object drops to 0, if nobody is pointing to an object, Java marks that object for deletion, for garbage collection. That doesn't mean that as soon as the object doesn't have any references pointing to it, okay, it means that whenever memory is needed, okay, so garbage collection is not done whenever the number of references to an object drops to 0, okay. Garbage collection is done whenever some object, whenever some memory is needed. So in Java, there might be many objects in your memory with a reference count of 0. Still, they are alive. They are not distracted. Okay? They are not deleted. Java waits. Okay? When the time comes, Java says that, okay, I'm going to do some garbage collection. I am going to delete, okay, all the objects with 0 reference counts. That's the Java garbage collection. So it's like the garbage collection in the regular real-life cities, okay? Your garbage is not picked up, okay? Your garbage is not picked up when you put the garbage out. It will be only picked up, okay, in the morning or in the afternoon or whenever it is needed, whenever the manipulator says that I am going to pick up the garbage now, okay? Or the garbage collection company or whatever it is. Java works like that. So whenever that garbage is collected, whenever that object is deleted, the finalize method in your class will be called. Again, finalize is not the same as destructor, but the ideas are is similar. Okay, so all classes in the Java in Java have finalize method. The finalize is not called by you, okay? Finalize is called by the garbage collector when it performs termination housekeeping, and finalize takes no parameters and has no return type. Has a return type of void, sorry. Okay, let's look at this example. One example, I think it will be clearer. A very simple employee class, okay? First name, last name, and we have a private static integer count 0. This is how you initialize your private data members in Java. Your first name, last name of the employee, and this is your constructor. Constructor sets the first name and last name, and increments the count, and it has this small printf statement. It prints the first name, last name, and count. So whenever you make an object, okay, it will print the first name, last name, and the count on the screen. And here is our protected void finalize. It is protected. We don't call it because nobody is going to call it, okay? It is protected. So every time an employee object is killed, okay, I decrement the count by 1, and I print out this statement. Now my name is this, last name is this, and count is this. And our regular setters and getters. Get count is a static member method. So the usage of the static is very similar to C++. Okay, and this is the end of the class employee. So this is employee.java. Okay, let's look at this employee test.java. Employee test works like this. Okay. At the beginning, see employee.getCount. Employee is a class name, so getCount is a static method. So I could do that. So this will print out 0, right? When I make this call, employee E1, employee Susan Baker, okay, so this will print out Susan Baker count 1. And when I do this, it will print out Bob Blue count 2, right? And then I will call get count on E1 and E2, okay? I will call get count on E1 and E2, and both of them will return 2 because the number of objects are 2. And then employee.get count again will print 2. Okay, no problems. So up to now. Now again, line 25, 24 and 25. It will print the first names of the last names of the employee 1 and employee 2. No problems. Now we are going to do this. E1 null and E2 null. Okay. Now E1 and E2. E1, let me try to draw my regular memory configuration. So I have two E1 and E2. E1 points to some memory location. Okay. Susan Baker, and E2 points to some other memory location. What is it? Bob Blue. Okay. So these two. Now, and both of them, the object count is 1, and object count is 1 here. Okay, both of them are 1. But if I do this, E1 gets the value of null and E2 gets the value of null. So what's going to happen? These will two go away, and this one is null, and this one is null. How about the object counts here? Object counts will be now 0 and 0. Okay, that means that the garbage collector can come in and destroy these two objects. But it is up to the Java virtual machine to initiate the garbage collector. The fact that these has the reference count of 0 doesn't mean that immediately the garbage collector will come in and destroy them. Okay, so destruction time is up to the Java virtual machine. So I cannot say that after line 31 this object will be destroyed, or after line 32 this object will be destroyed. I cannot say that. Okay, it might happen. Okay, but most probably, since I have lots of memory space, Java garbage collection will run later, some later time. Okay, but we can force the Java garbage collector to come in and pick all the garbage. Okay, do the garbage collection by doing this. System is a class name. GC is a static method. Garbage collector, GC means garbage collector. I am saying that, okay, do the garbage collection right now. When I call line 34, garbage collector will destroy all the objects that have a reference count of 0. So when the objects are destroyed, their finalized methods will be called. Where is my finalized method? Here is my finalized method. Okay, so it will drop the count by 1 for each object, and it will print the names and the count on the screen. Okay, so that's what the line 34 will do. Okay, it will force all the objects with 0 reference counts to be deleted, destructed. And then this one says that now let me print out the count. Now the count is going to drop down to 0 now. Okay, but if I do the same thing, okay, if I say print line, okay, here's a question for you. Print line employee dot get count. If I write this statement here at line 33, it will give me a syntax error because I didn't. Okay, print line. Okay, So what would I get at line 33? It will print a number on the screen, but what would be that number? 0, 1, 2, 3, 4, 5, what?
2.
Who said 2? Mustafa said 2. Mustafa,
Yes.
I cannot say you are correct, but also I cannot say you are right. So what is the answer?
The finalized method decrease the value of a count, I think.
Well, how do you know that the finalized method is called at line before line 33?
I assume that system.gc called it.
Well, you cannot assume that. Okay, I mean, when the system, system.gc is called at line 34. I wrote this at line 33. So it is not called, but it might have been, right? We don't know, okay? So line 33, there are 4 possibilities. It could be 0, it could be 1, or it could be, there are 3 possibilities. There are 3 possibilities. It could be 0, 1, or 2. Because if the garbage collector is never run, then it is 2. If it is run after this line 31, because we don't know, okay? Garbage collection can be run anytime. We don't. It is not in our hands in this case, in this example. Okay, but I definitely know that after line 34, garbage collector is run, and our finalized methods will be run, and it will decrement the counts down to 0. Okay, good. So this line 33, I don't know. I think it could be 0, 1, or 2, but definitely line 40 will print 0. Okay, and this is the sample output. Employees before instantiation, employee.getCount will return 0. Employee constructor for Susan Baker is count 1. Bob below is count 2. We know those. And then I use all those get counts using D1, E2, and employee. They're all 2. And then when the finalizer called on the, okay, who is doing this? Okay, of course our finalizer method is doing that, but who is calling the finalizer method? Garbage collection. Okay, garbage collection is doing that. Okay, so first Bob Blue is deleted, then Susan Baker. And we wouldn't know the order of the calls of these objects. Good. Any questions so far?
Should we implement the finalizer? Do we have default finalizer like CPP?
Well, the slide says, okay, all classes in Java have the finalize method. You have a finalize method, but it doesn't do anything. Now you might be saying that, I mean, at the beginning when I told you that when I say class A in Java, it is as simple as this, and there are no like big tree and that kind of stuff and assume stuff. And now you are giving us new stuff like the finalize method. You never told us that, and now you are saying that there is a finalize method defined. We will talk about this, and this will make sense. Okay, there is a reason why there is a finalize method for all the Java classes. We will talk about it later, and it will make everything clear. Okay, any questions? So when should you write finalize methods in Java? Usually, I mean, remember, when do we write the big 3 in C++? The big 3 in C++ is needed if I need my own copy constructor or assignment operator, but in that case, usually it happens with the pointers. In Java, the pointers are handled by themselves. Okay, the destruction is done by the Destruction is done by by ourselves in C++. In Java, destruction is done automatically. So most of the time we will not need the finalize method. But for cases like this, for example, you need to decrement some value. You need to maybe close a network connection. Okay, maybe close a file. Okay, maybe do some other stuff when the object is going away. So in that case, you need to write the finalize method, but it is not written as often as C++ destructors. Okay, any questions?
So I just read about system.gc online, and it says it doesn't call immediately the finalize methods.
Let me see. Okay, Oracle system.gc. Class system, the fields and methods. Let's see where is system? Okay, here. Runs the garbage collector. Calling the GC method suggests the Java the virtual machine effort towards recycling unused of to make the when control returns to the okay, suggested that the virtual machine expand. So it is a suggestion. Okay, I mean, this doesn't say the conditions when it is run and when it is not run. It is not guaranteed, yeah. But it doesn't say anything more than that. Even that one is not guaranteed. I am guessing it is for, okay, do you remember we said something about smart pointers? If you have things like this, let's say I have a linked list, okay? Somebody is pointing to that one, and that, and that, and this one is pointing to this. So what are the object counts for each one? This one is 2, this one is 1, and this one is 1, right? Let me use 2, 1, and 1. If I delete this one, okay, if I delete this one, then this 2 will be, this 2 will be, this 2 will be 1, right? And this is 1, and this is 1, and this is 1. So I have a circular reference happening here, and even though there is no way I can access to this linked list from the rest of the program, since the reference counts are greater than 0, nobody is going to destroy them, but they are junk, right? They are not accessible. Java has ways of making sure that these will be picked up too, but it has to run some special code to check these kind of circular reference stuff, and this is expensive, okay? And there are many other details of garbage collection. Garbage collection is not easy, okay? So that's why I guess they are making, they are keeping themselves keeping themselves safe by saying that this is just a effort recycling, okay? Sometimes I may not collect some of the objects that have a reference of, that are supposed to have a reference of zeros, okay? But I mean, for this case, I don't see any reason why these wouldn't be picked up in this case, okay? Good, okay, that was a good catch. Who said that? Somebody read the documentation? Who read the documentation? Who didn't trust me to read the documentation while I am talking about the garbage collector?
It wasn't at the same time. I read it before.
Okay, you read it before. Good. Okay, so So that's the way I like you to learn something. Don't trust me. Okay, read the documentation. That's why we say that the destructors and finalized methods are so different. Okay, we don't know when the garbage collector is going to be called, and even if it is called in this case, even in that case, it may not be. If the garbage collector is called, some of the finalized methods may not be called. Okay, good. So we looked at this example now. Okay, so what we said before, there is no const keyword in Java. Okay, so what do they do without the const keywords? There are no const methods. Okay, but instead of using the const methods, what is the Java solution? Java says that why would I use a const method mechanism? Okay, I will make classes like string. String is an immutable class. You cannot change string because there are no methods of string that will make it change. So we will solve our problems that way. Okay. So, but sometimes we need to tell the compiler that this value will not change. Okay. And the idea is like const, but the mechanism is not like the const. So they invented this new keyword final. Okay. Final instance variables. Keyword final, and we are going to say it. Okay. If you say this instance variable or this data member is final, then nobody is going to change it. If you change it, you will get an error message. Here is an example. I have a simple class, increment.java increment. Okay. In the increment class, very stupid class, there is a total private integer. It is not final, but int increment, capital letters, capitalized. Okay. Int increment is a final. That means that nobody can change it. But we did not initialize it. So I am going to initialize it in the constructor. So how come I can change something that is constant, that is final? But constructors have these kind of privileges, right? Remember the constructors? Inside the constructors, I could change the constant data members in C++ too. Otherwise, how can I initialize them? You might say that you initialize them here. Okay, you would say that okay, this one gets the value of 7. You might say that okay, I initialized it, so it will be fixed afterwards. But if I like to change the value of this constant integer different for each object, what am I gonna do? I mean, I like each object to have a different increment value. Okay, for each object it will be constant, but it will be different. So what am I gonna do? You are going to do this. You are going to do this. You will not initialize it, but you will initialize it in the constructor. Okay, you initialize it in the constructor. And I have this add increment to total method. It will change the total amount by the increment. And I have this toString method. toString is a special method. Whenever Java needs to print something, okay, this is very similar to okay, very similar to C++ overloading of stream insertion operator. Okay. So when you say, let's say I have an increment object, increment inc new ... okay, I did some stuff, and in a print line statement I said print this increment. Okay, Java says that okay, this is an increment, reference to an increment object. Okay, how am I gonna print it? I know how to convert this increment to a string. It is toString method. So it will call toString, and toString will return a string, and that string will be printed by this print line. So all the Java objects, they know how to convert themselves to strings using the toString method. So toString method is defined for all the Java objects. Another detail you might say for the Java classes. So this Java class A is not as empty as it looks. Okay, so far we said that there is this finalize method, there is this toString method is available, and there are a few more others. Okay, but again, there is a good explanation for that. It is not like big three. It is not like, okay, there is a rule that says this, that. Oh, no, there is a very simple rule, and and it will be very, very logical. So there's, how do you convert a increment object to a string? This is what you do. String class, there is a format static member method, static method. You would say this format is same as what? Look at this format. Do you remember this method from your C courses? What does it look like? What does the format do? It returns a string, right?
Printf?
It looks like printf, but it is not printf. No, it is. Yeah, it is very similar to printf, but it is more than printf. It is
scanf.
as printf. Okay. String printf. As printf takes a string, okay, and the format and the stuff, right? This one is doing exactly the same thing, okay? As printf. As printf. It takes one character array, another character array, and the stuff, right? So this will say that my total is this, and it will return it. Okay, let's see the driver code. Increment test.java main. My new increment object will take the increment value of 5, and this is my value. What do I do now? See this one? This one says that I am going to print a string on the screen, and I am sending value as a parameter. But value is not a string, but Java knows how to convert each object to a string. Okay, so before incrementing value, what is, okay, total is this, okay, it will print it. And every time I add, I call this add increment to total, it will add 5 to the total. And every time I print the value of I and the value is an increment object. So it will be this. So at the beginning, total is 0, now 5, 10, and 15. Okay, so this is the final instance variable. You don't use final. Here you cannot. You don't say that. Okay, this is not const. Okay, don't use final as const. Okay, final has a different meaning. Well, in this case, the meaning of final and the meaning of const in C++ would be the same for line 7, but other than that, the meaning is different. Okay? Good, any questions? Any questions? Okay, if there are no questions, which is just scary for me, I'm very scared. I will continue. Okay. We said that in Java there are no header files. Yes, that's what we said. Okay. And for some reason, I don't know. Nobody has asked me a question of, okay, this increment test Java is a Java program. This increment.java is a Java program. I compile this one. Okay, let me write it here. When I compile it, Java compiler increment.java, this will produce me an increment.class file, right? And then Java compiler increment test.java, this will give me an increment test.class. So how am I going to run my program? What should I type to run my program?
Java increment test.
Exactly, Java increment test. That's what I'm going to do. But how does increment test know the position for increment.class, right? I mean, I never said in my increment.test there is a file named increment.class or anything like that, right? So I mean, we never said that. I mean, previously we use this include files, and the include files now give us the definition of the class itself. And when I link my program, I say that this is my object code for the increment.o, and increment test.o is here too. So I link them together and make a new program, right? So however we're gonna do that, okay, Java assumes that when you do that, okay, when you do this compilation, Java assumes that when I do the increment.test compilation, okay, when I say increment 5, how does the Java know that there is a class named increment and it has a constructor that takes an integer? So okay, Java says that okay, in the same directory there must be a Java increment.class file. Okay, so that increment.class file defines everything. So the compiler reads that file and figures out everything about the class itself. So all the .class files should be in the same directory when you compile all of your programs. Okay. Also the same thing valid when you run all your program increment test, Java increment test. All the required .class files should be in the same directory. Okay, should be in the same directory. That's how Java compilers and Java virtual machine works. But for small projects, this kind of works. Okay, that's fine. How many files can I write for a small project? Maybe 4, 5, 6, at most 10, 12, right? Okay, that's manageable. But if I have in my large enterprise application, if I have 2000 Java classes, 2000 Java files, what am I going to do? Can I keep all of them in the same directory? Theoretically, you could, but nobody's going to understand what's going on in that directory. That would be very complicated. So I need to organize my stuff into smaller modules. So we call them in Java, okay, like the libraries, packages. Okay, packages. You will say that, okay, I will make a class set, maybe set of classes, and I will put them in a package. Okay, remember the standard packages: Java utilities, Java language, Java abstract window toolkit, etc. Okay, those are all package names. You could say that in my large enterprise application there are more than 2000 files, but I have 15 packages, and each package contains maybe 50 Java classes, and each one is documented very, very well. So then there should be a way of declaring and creating packages, and this is how we do it. Okay, once you make a Java package, it becomes like a library now. Okay, it becomes like a library, and you could use that library anywhere you like by importing that library or package. Okay, so this is how we are going to do that. Let me show you one example here. Say that, okay, this is my package name. I am creating a package, and this is the convention in the Java community to create packages. It says that you use your internet domain name in reverse order. This book is detail book, right? Java How to Program, Chapter 8. So, com detail Java How to Program 6, Chapter 8 is my package name. If I am using, if I am making a package out of this Gebze Technical University, maybe my package name should be TREDU, okay, GTU, Computer Science 241, and maybe, let's say, vector. My vector package of 241 class. So this package name will never have a chance of colliding with somebody else's vector class, right? Because it's a very unique name. This is the kind of convention for the packages. Okay, public class time 1. I have my hour, minute, and seconds. Remember, I mean, this is set time. Just make sure that everything is right. That's it. This is my package. Okay, I have 2 string method and 2 universal string. I skipped this. And after I created this package, okay, whenever you need this time 1, whenever you need the objects of this time 1 class, you import this package. Okay, import com.detail.java how to program 6, Java how to program 6, and chapter 8, and you import it. Okay. So where do I put this library? Where do I put this Java package? You put them in any place that you like. Okay, any place you like, and in your environment variable lib path or class path environment variable will hold the directory names for all of your Java packages. Let me see if I can cmd. So this is DOS environment. Does echo work here? Yeah, echo $, yeah, $ class. I am not sure if this thing is defined. No. Echo class path. How about this? How did I do that in DOS? Let me try it in the fake Linux shell. Path is here, okay. Let me try to do class path. No, I don't have it. It is not defined. How about lib path? It is not there either. So it is operating system defined, okay, and this environment variable will hold. Okay, if I show you again. No, if I show you this here again. This path environment variable holds the position of the directories where my executables could be. Okay, user local sbin, user local bin, user sbin. So these are the places. When I say, for example, when I say wc, okay, wc is a Unix utility, and it must be in one of these places. Let me see, where is wc? Where wc? No. So which? Okay, so wc is in user bin. Where is my user bin? Is user yeah, user bin is here. See? So when I say wc, it will look at under this directory. It is there. It is not. It will look at this one. If it is there, it is not. Then this one, no. Here I found it. Okay. So it is scanning all these directories one by one. Class path is something like that. Okay. When you try to import something, it will look at all the directories under this class path environment variable, and once it finds it, it will import it. Okay, so whenever you add a new package, you will need to update your class path, or you need to put all of your packages under the standard Java directories, and that will be fine. Okay, any questions? No questions.
Can we give special name package?
Special names, I mean, this is as special as you can get, right? You wanna go even more special than that? I mean, it is up to you, whatever name you give your packages, but with the packages, you need to be careful that nobody else in this world should have the same name, okay? Don't use very common names for your packages. So if you say TREDUG2, that means that the only people that can have the same name packages are the people at Gebze Technical University. When you say computer science, now it is more special, and it cannot get any more special than that. So it is up to you what name you give your package, but you need to be careful about the collisions. Okay, any other questions?
Can we have unnamed packages?
Unnamed packages? No. Well, no. You mean like unnamed namespaces?
Yeah.
No. Unnamed namespaces are something special to make. Okay, that's a good question. What is the corresponding method in Java, okay, that has the same meaning or the similar meaning as the unnamed namespaces? Are there unnamed namespaces in Java? No, there are no namespaces in Java. Okay, there are no namespaces in Java, but there are packages. If you like to use a namespace idea, okay, you do this. In a class, okay, let's say I have a class public class A. In my class there are private elements, there are public elements, private integer A, public F, public void F, okay, does something, and maybe a protected double D, and then you will say integer M. Okay, this integer M here has the default access property. Okay, this is private access property, public access property, protected access property, and this is the default. Default means that this integer is only accessible inside the same file as this A. Okay, so this is like unnamed namespace. So if you are using the default access modifier, not private, not public, not protected, okay, it is default. Those default members of classes, okay, those default members of classes, or sometimes inside the same file, let's say this file is named, a.java. So that means that there has to be a public class A inside it. But if I have a class B that does something, see, I did not say anything about this class B. Okay, I didn't say that this class B has a public, private, protected stuff. Okay, this has a default access property. Okay, that means that this class B is only accessible in the same package. Okay, so this is very similar to unnamed namespaces. It will not be visible to others, whoever uses this package, but this class B or this integer M will be available only in the same package. Okay.
Thank you.
So there is one more access modifier. Okay, access modifier in Java: public, private, protected, and default. And default behaves like the unnamed namespaces. Similar. It is not exactly the same, but similar. Okay, I think I am late for giving you this 10 minutes of break. So let's give a 10 minute break. Let's be here around 10:38. Okay? 10 minutes of break. Okay, so this is how you do the packages. And let's talk about inheritance. The idea of inheritance is the same, software reusability, okay? You make a new class out of the existing classes. You say that I am inheriting everything that this class has, but I will add new functionality to it, okay? So the idea is the same. The mechanism is very similar, but of course there are some similarities and differences. First, let's look at the differences. Terminology, okay, let's do this. So C++ and Java. In C++, inheritance. In Java, inheritance, no problem. It's the same. In Java, we use this term derivation. In Java, it is not derivation, it is extension. Okay, we extend the classes. We don't derive classes. We extend classes. In C++, we have base class. In Java, we call that superclass. Okay. In Java, we said it is derived classes. In Java, it is subclasses. Okay, subclass, superclass. It's like supersets and subset. What else do we have? I think whenever I remember them, I will put them up here. So the ideas are the same. The names are different. The names are different because Java tries to use the standard object-oriented programming language terms, okay? And C++ made its own terms like the base class and derived classes. Okay, let's see an example. I think this is what we are going to do. We will have a commission employee, okay? Commission employee, and we are gonna extend base plus commission employee. In the commission employee, we have the first name and the last name of the employee, also the social security number. Remember how the commission employee works? It has each commission employee has the gross sales and the commission rate. Okay, it has gross sales and the commission rate. I think my network connection is disconnected a little bit, and I'm back. I think I'm back now. Yes, I am. So the commission employee, remember how the earnings of the commission employee works? It says that this commission employee sold $1,000 worth of goods, and the 5% commission rate So 5% times 1,000 is $50 is for you. Okay, so that's the commission employee. So the commission employee constructor, first name, last name, social security, sales, and rate. I am using these assignment operations and the setters. And the set first name, get first name, set last name, get last name, set social security number, get social security number, and gross sales. Okay, it has to be positive. Get, set. Okay, these are all get, set stuff. And hello. What? Okay. Hello again, everybody. I think there is a problem with our internet connection at the university campus. So I couldn't connect. I am using my cell phone right now. And I guess you are not seeing my screen. Where is my screen? Yeah, here is my screen. Can you see my screen now? Do you see my screen? Do you hear me? Yeah? What did my... Okay, so you are hearing me right?
Yes.
Okay, so yeah, okay, so it works with my cell phone. What did I say? I said that, okay, this is the commission employee, and I told you about everything. And remember two things that we are gonna extend this base, this super class with the new base plus commission employee class. That's what we are gonna do. This new subclass. And we are going to add some new functionality, and we are going to change the meaning of what? Get commission, no, earnings, right? Earnings will be different for the base plus commission employee. Okay. Well, I think at this point there is a good opportunity to ask a question. shouldn't we, you should ask a question. Okay, your question is this. Shouldn't we declare dot 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 dot? By looking at this slide, remember this is our superclass. You are supposed to ask a question here. This is our toString method. Okay, you think about that question. You are thinking about what question to ask now. First name, last name, social security number. Okay, these are all printed using the string format. You are supposed to ask me a question right now. You are supposed to ask me, shouldn't we declare this method dot 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 dot?
Is it toString method?
Well, we have the toString method. No. You should be asking me some question saying that I think that this declaration is wrong. The correct declaration should be such and such.
Plus operator instead of comma.
Mohammed, I did not understand what you said.
String format in total string add to each other isn't be found there.
Well, I did not compile this program, but it is compilable program, and I think first name, last name, social security number, and new line, then no, first name, last name, first name, okay, this three, then social security number, then gross sales is no, this format is correct. And my question is not about toString. Okay, let me make this even. Okay, the question is about here. Because if I keep that string on my screen, you're going to ask more questions about string. It's not about toString, it is about something else.
Using get commission rate instead of commission rate field.
No, well, I mean, that would have been nice, but we don't have to. I mean, it is not that critical. I am talking about the earnings method, okay? Earnings method is supposed to be what? Think about it. It has to be virtual, right? Why? Because we are supposed to use the earnings method using a reference to the superclass and etc., but they didn't make it virtual. Okay? They are not using any virtual. Remember, the earnings, we used to have it as virtual. They don't have it virtual. Then there is a good reason for it. Okay? And we'll talk about it when we talk about the polymorphism. So keep this in mind that earning, okay, should have been, okay, virtual. Okay, so this is the superclass. Let's look at the subclass. Subclass is base plus commission employee, and it is written exactly like this. We say that, okay, public class, base plus commission employee, it has its own base plus commission employee file, and we say that it extends this superclass commission employee. Okay, it extends this commission employee, and I have this private double base salary is the new field other than the name, last name, social security number, etc. And my constructor will have now one more parameter: first name, last name, social security, sales rate, and salary. Okay, so this is the new stuff. I sent all of the first 5 parameters to the superclass constructor: first, last, social security, sales, and rate. These are all sent to the superclass. Superclass constructor will handle it, and this is how you call the superclass. Okay, remember in C++ we used to do this. We used to do, okay, commission employee and first, last, SSN, etc. This is how we did in C++ 11. Now in Java we don't do it that way. It is like calling another constructor. Okay, how do we do the calling the other constructor stuff? We do it this keyword. Now we are doing it with the super keyword. Super is a new keyword in Java. We don't have it in C++, and it is used to call the superclasses constructor. And again, related to this new field, I have the setter and getter. Okay, now I have my earnings. Okay, I have my earnings. Base salary plus commission rate times gross sales. Instead of doing this, I think this would have been better. You would say base salary plus super dot earnings would have been much better. I don't have to repeat it. And by the way, since let me go to the superclass. Okay, since all of them are protected, all the fields are protected, it is okay for me to access them from this extended class, subclass. Okay, I can access the superclasses protected fields. Okay, that's what they did, but I think this is what I am doing is better. Okay, the same thing for the toString too. Okay, I would say okay, get rid of all of them. I don't want these, because these are already, I have done that, right? Okay, so I would say return super dot earnings plus then this format.
Can we call this override?
Sure. I mean, these are not redefinition but overriding of the superclasses virtual methods. We are overriding them. Yes, that's true. I mean, to override something, it has to be virtual, right? And I didn't use the virtual keyword, but in a few minutes I will talk about it when I talk about the polymorphism in Java. Okay? Any questions? Good. Okay, that's it. Let's look at the test code. Base plus commission employee test. I have base plus commission employee object here. Bob Lewis, social security number, gross sales, commission rate, and the weekly salary. Okay. And I printed this stuff: print line, printf, first name, last name, social security, gross sales, etc. So I tested all the methods. Okay, and I call this employee to string. Everything works. Okay, so this is basically how the inheritance works in Java. Of course, inheritance means is a relationship. We did the composition before. Doing composition is easy in Java. Okay, so how we are gonna use this is a relationship is very similar to how we use it in C++. Okay, with the is a relationship, we say that all the base plus commission employee objects are commission employee objects actually. If I have a method void method m1, if that method expects a base plus commission, okay, commission employee E, okay, I have such a method. I could call this method m1 with a base plus commission employee object because there is a relationship between them. Okay, we know that. And question, is there the slicing problem in Java?
We
This
don't have pointers.
Atakan, say that again.
We don't have pointers, so it is not.
But this is a pointer. When does the slicing happen in C++?
If we copy the objects each other, and if they are different, then there will be a slicing problem. But since we are shallow copying, actually, we are copying references, I think there is no slicing problem in Java.
Slicing problem happens, or maybe I shouldn't call it problem. Slicing happens when you make a call by value, right? Or when you do the assignment, copy assignment, using the is a relationship. Right? That's when it happens. But in Java, we cannot do any copy assignment, right, of the objects, or we cannot do the call by value of the objects in Java. So there is no slicing problem in Java. Okay, we don't have that slicing thing in Java. They don't talk about it. Okay, if you call this method with a base plus commission employee, slicing will not happen. Of course, this commission employee cannot access the salary field of the base plus commission employee object, but the object will be there, so there is no slicing happening. Okay, good. So other than that, there is not much to say. Maybe give you more examples and it will make it clearer. Okay, so let's talk more about inheritance and let's talk about why inheritance is so important for Java. Okay, of course, inheritance has to be important for Java because inheritance is one of the four principles of object-oriented programming, but inheritance means even more for Java because there is a class named object. Well, it's a weird name for a class, but there is a class named object with a capital O. Okay, that object class is special. Why? Because all the Java classes, like it or not, there is no other way, all the Java classes has to extend from this object class. Okay, all the Java classes, when you say I have a Java class A, okay, this A class A extends from this class object. So inheritance works. Whatever this class object has, through inheritance, this class A will have it. Remember we said that all the classes in Java has a finalized method, and all the classes in Java has a toString method. That's why they have it, okay? Because in object class, you have all these methods available, all of them. So whatever you do, you are going to inherit all of these methods from the object class. Even if you have a class like that, okay, it will have all these methods implemented for you because of the inheritance. And in C++, we didn't have anything like that, but instead we said that any class like that will have big three, or any class like that will have the no parameter constructor, the destructor, and the copy constructor, default assignment, etc., etc. So we made them those kind of exceptions, and we were very careful about listing them, etc. Now we are not that careful anymore. We say that, okay, all the classes, Java classes, has to extend this object class, and object class has these. So by the definition of inheritance, I get all of these methods. So what are we gonna do? Let's look at the definition of each one by one. Okay, let's look at the definitions of each one, starting from clone. Some of them I think I will not talk much about. Some of them we'll be talking about. Okay, clone. Clone corresponds to, kind of corresponds to copy constructor. Okay, in Java most of the time, we don't need the deep copying of objects. Okay, shallow copying will be okay. So reference copying will be fine. But if we need to, okay, make a deep copy, then we have to override this clone method. Okay, this is a protected method. Usually we cannot call it from outside, but if we like to write our own clone method, make it public and write a clone method that does the deep copying. The default meaning of this clone is shallow copy. Okay, shallow copy by means. Okay, let's look at the shallow copy of this class. Okay, if I do the shallow copy of a commission employee object, the first name will be reference copied, last name will be reference copied, social security number will be reference copied. Since these are primitives, they will be just copied. So the shallow copy of commission employee, shallow clone of commission employee will be fine, because those strings will be immutable, they cannot be changed. So I am fine. So for this commission employee class, I will be okay. Okay, because those things cannot be changed. Those things cannot be changed. I know that. Okay, good. So for most classes, the default meaning of clone will be fine, the shallow copy. If you need to make a copy of that object, then you're going to use it. But this copy for most classes is so rarely done. They made this clone protected. If you don't override it, your clients won't be able to call this clone on your objects. Okay, so even though it is available, your clients do not have access to it because it is protected. Okay, depending on how much time we have, I may or may not look at how we write a clone method for our objects. Okay, good. That's one of the methods of the object class. The other one is equals. Okay, so let's do this. String S1 is new string ABC I'm trying to do the same thing, exactly the same thing, duplicate it, and string S2 is like that, exactly like that, and I have string S3 and S4. The value of S3 is same as S1, value of S4 is same as S2. Okay. So tell me the value of this one. S1 equals S3. Is this true or false? Is this true or false?
False.
It is false.
Because of the references.
Because S1 points to an object, S2 points to another object, and S1 compares S2. Okay, S1 compares S2 is a different thing. Okay, those are pointing to different stuff. What happens if I do this? D, E, F. It is still false. Doesn't matter if their values are the same or not, okay? And in fact, let me make a copy of another one and duplicate it. Okay, let's make this S2 and this is S5. So S1 and S2 is false definitely, even though their contents are exactly the same. How about this one? S1 equals S3. True or false?
True.
This is true. Why? Because they are pointing to exactly the same object. Okay? Okay, and of course I know that S1 equals S5 is again false. Okay, so that means that on our objects, I mean, this equality operator is equal to operator doing the reference check. What if I want to check the contents? Then in that case, this is what you're gonna do. You will say that S1 equals. How about this one? S1 equals S2? True or false? Well, I didn't give you the meaning of the equals, but you're gonna guess. It is true because their contents are exactly the same. How about this one? S1 equals S5. S1 equals S5? S1, no. It is false. Why? Because their contents are different. False. How about this one? How about this one? S1 equals S4. True or false? It is true. Why? Because S2 points to the same object as S2. S4 is the same as S2. And S2 is pointing to an object that contains ABC. And S1 contains ABC. So it is true. So equals method is a Boolean method. It returns either true or false. Okay. And it will supposedly do the comparison of the content of the objects, okay? And unfortunately, the default meaning of equals is the same as this one. If you have a class, okay, you have automatically your equals method defined for you. And the meaning of equals method is the same as reference comparison. Remember the class A? My favorite class A. Okay, my favorite class in both C++ and Java. Okay. The meaning of equals, okay, is the same as equality operator. If you don't override it, then that's what's going to happen. For string class, of course, they have overridden this equals method for us. Look at this definition of equals. It's an object. It takes object. Okay, let me try to open up the documentation. Open up the documentation. Can I find? Okay, let me go back then in that case. Oracle Java object class. Let me show you the object HTML. Okay, so this is clone is protected. Okay, Boolean equals C, it takes an object. That's why I don't like this name object for a class. It takes an object. Okay, so it doesn't take a string object. Why it cannot? Because equals is a method of the object class, and in the object class you don't have anything else. Okay, good. Okay, so we need to be careful. So because of the is a relationship, it's going to work for all the cases. For example, you could say okay, S1 equals my money. Let's say my money is a money object. Okay, the compiler will compile this. What do you think it will return? What does this equal return? Are you guys hearing me?
Yes,
Yeah.
There is a delay. Well, okay, maybe can I switch back to the university network? Maybe they fixed it. Are you guys hearing me right now? Yeah.
Yes, we can.
Okay, this is better. So maybe I can switch off my cell phone and I'm going to save some megabytes. Okay. So what is this supposed to return? If you compare a string with a money, what is it supposed to return? This is not a trick question. It is not that difficult. Equals as the documentation says, equals takes an object and money is an object. I send an object to it. The compiler took it. Okay. And how would you implement this equals method then? How would you implement this equals method? What would be the first line in your equals method? I need the answer to this question. This is so important. What would be the first line of your equals method?
Can we downcast in the Java?
Yeah, that's a very good question, Kamil. Yeah, you should downcast it, and there is a downcast operation. you should downcast the object to a string, right? If it is downcastable, then you make your comparison. Otherwise, you return false, right? So the first statement of your equals method, if you are overriding it, is to downcast to a string for the string class. Did everybody understand this? This is so important. This is so important to understand the equals method in Java. This is so important to understand how downcasting and why downcasting should work. Also, this is so important to understand what polymorphism is. Okay? Did everybody get this?
Sir, I didn't understand what downcasting is and what is it related to this.
You don't know what downcasting is? Downcast.
Not exact.
Downcasting. See, as S1 equals, S1 is a string, right? If I am overriding the equals method for a string, I would expect a string, right? But equals is defined in the object class as like this. Equals takes an object. Object, okay? Object class instance. Since it's an object, I can pass anything that I like because everything is object in Java. All the classes has to extend the object class. So I could, theoretically, in practice I can do this, I could send a money object to the equals method. But how am I going to compare a money with a string? I mean, they are not equal, right? So how am I going to know that the object passed is a string object, okay? So I am going to do this. Since it's an object, there is this relationship between, okay? This is my object class, and this is my string class, and this is my money class. Is a relationship. The method equals needs an object. Because of the is a relationship, I could send money objects or string objects to this method. If I send a money object to it, it will work, but this method has to make sure that whatever it receives is a string. So it is going to make a downcast to the string class first. If downcasting works, then it will make the comparison. If the downcasting doesn't work, then it will say that no, false. These two are not equal because they are not the same class. They are not the same class. Okay? So this is a very fine point. Maybe you might think this is a detail. No, this is not detailed. Okay? Understanding this crucial to understand the main Java object class structure and the main Java ideas. Also understanding this is important to understand the idea of polymorphism. And we will come to this more often. But I think I am running out of time today. I think I will stop here, and tomorrow we will continue from this position. But I can take your questions if you have any. Mehmet Avni, did my answer make any sense for you?
I didn't ask any question.
Who said that I did not understand this downcast? Süleyman, you asked it? Okay. So did my answer make any sense for you?
Yes, sir. Thank you. Thank you.
Okay, for the other people who are shy to ask that question, okay, just I am recording this and listen to this question again as explanation again by watching the video again. And if you have a question about this again, ask me tomorrow morning, and I will see you tomorrow morning. Okay, that's it for today. I will see you tomorrow morning.